Okay, hello, all elective honors geometry. So I'm recording this on Zoom while you guys have class and I am away. Please watch this. This is going to be a little awkward for me. I haven't rehearsed it. I'm not really talking to anyone. I'm talking to myself, but we will do our best. The blanks are online. You could just copy the blanks if you want, but I thought you might want to watch this if having my voice kind of walk you through it is helpful to you. So let's get started. So this is 8.4 proportionality theorems. So we are skipping 8.2 and 8.3. This is just 8.4. So proportionality theorems. Proportions are fractions. So essentially these are all different equivalent fractions we could set up. So the triangle proportionality theorem says that if a line is parallel to one side of a triangle, if a line is parallel to one side of a triangle and intersects the other two lines, or rather other two sides, then it divides those two sides into proportional pieces. So if you remember, the mid segment of a triangle was right in the midpoint of these lines. Now this kind of line could actually be anywhere as long as it is parallel. So here we have QS and TU. So if QS is parallel to TU, then what it's saying is these pieces are the ones that are proportional. Those pieces are the ones that are proportional. So you could say QT over TR. QT over TR would equal SU over UR. Or you could write it as QT over SU would equal what? So it's short over short, long over long. We've talked a little bit in 8.1 that you can set up proportions in a few different ways and still have them be equivalent statements. Now the converse of that now is the converse of the theorem. The theorem says, all right, if that line is parallel to this, then those sides are proportional. You can imagine the converse proves that it's parallel. So in this case, if a line divides two sides of a triangle, into proportional pieces, then that line is parallel to the third side. So this one goes the opposite way. For instance, if QT over SU was equal to TR over UR, or the other way we set that up here, then I know that QS must be parallel to TU. So that's the triangle proportionality theorem and the triangle proportionality converse. So let's use those. So here it's saying if QS is parallel to UT and RS is 4, ST is 6, and QU is 9, what is the length of RU? Now keep in mind, RU is actually this whole piece. So first, let's find this missing piece. Let's call it X. There's a couple ways we could do this. X over 9 would equal what? Well, if you're doing X over 9, again, we know they're proportional because these are parallel. X over 9 would equal 4 over 6. We cross multiply, you get 6x equals 9 times 4 is 36. Divide by 6, x is 6. Now remember, that's not your final answer, that's just what x is. You want to remember, RU would be x plus 9. So RU is 15. All right, similarly, now determine if ST is parallel to QR. So this uses the theorem. This uses the converse. So I want to see if they're proportional. So I want to know if 4 over 6 is equal to 3 over 5. Well, you can't reduce 3 over 5, but you can reduce 4 over 6. That would give you 2/3, which are not equal. So ST is not parallel to PT because of the triangle proportionality converse. So you could have also done 4 over 3 is not equal to 6 over 5. You would also do, the way you could set these up is like 4 and 10, 3 and 8, or here, x is 6, 6 and 15, 4 and 10. So the proportionality theorems can also, you could consider a whole side instead of just a piece. All right. And we have 2 more theorems today. One is the 3 parallel lines theorem. So if 3 parallel lines intersect 2 transversals. So 3 parallel lines I'd rather phrase that as if 3 parallel lines are intersected by 2 transversals. Now it's important to note that transversals themselves don't have to be parallel, just these 3 lines. Then they divide the transversals into proportional pieces. All right, so in this case, we could have, all right, so if these are lines R, S, and T, so if R is parallel to S is parallel to T, then what are a couple things we could write? Well, one thing you can talk about how these sections compare to these sections, because you're dividing this into pieces. So UW over WY would equal VX over XZ. Or what's another way you could put that? You could go from up, instead of left, right, you could do up, down, up, down. So UW over VX is equal to WY over XZ. You could have done UW and UY, VX and VZ. A lot of different options.